Let's see what is Bose-Einstein gas. Then we derive the energy for Bose-Einstein gas. Bose-Einstein gas is an assembly of bosons, and bosons are particles having zero spin or integral spin. If the spin is zero or integral, the particles are bosons. They obey Bose-Einstein statistics, and a collection of these bosons, that is the Bose-Einstein gas. And we know the Bose-Einstein distribution. The number of particles in the energy level EI is given by if GI is the degeneracy of the level, Ni is GI by e raised to alpha plus beta EI minus 1. That is the Bose-Einstein distribution. Here particles are bosons, therefore we use the Bose-Einstein distribution. And the value for alpha is minus mu by kT. K is the Boltzmann constant, T is the temperature in Kelvin scale, and mu is the chemical potential. Remember, alpha is minus mu by kT and beta is 1 by kT. Then we define a parameter A, capital A, such that 1 by A is equal to e raised to alpha, or we can write the inverse, 1 by A inverse A, that is equal to e raised to minus alpha. Same as that of this expression. So we define a parameter A, capital A, like this. And now we are going to find what is the range of this A, that is what is the minimum value of A and what is the maximum value of A. Okay, then Ni is equal to, we write this in terms of capital A, Gi by e raised to alpha. E raised to alpha is 1 by A, that is 1 by A e raised to beta Ei minus 1. And since Ni is a number, and we know a number means it should be positive. Positive means it should be greater than 0. At least 0. The minimum value is 0, and otherwise it should be greater than 0. And that is a condition for Ni being a number. So for this value to be positive, this term, this is the only term which can be negative. Minus ഒരേ ഒരു ടേം ഇതാണ്. ഇപ്പം നെഗറ്റീവ് ആവാൻ ചാൻസ് ഉള്ളത് ഈ ഒരു ഡിനോമിനേറ്റർ ആണ്. അപ്പോൾ ഇത് ടോട്ടൽ വാല്യൂ പോസിറ്റീവ് ആണെങ്കിൽ ദാറ്റ് മീൻസ് ദിസ് denominator should always be positive. That is 1 by A e raised to beta Ei should be always greater than or equal to 1. That is a condition. Denominator positive ആവാനുള്ള condition അതാണ് 1 by A e raised to beta Ei should be greater than or equal to 1. That is 1 by A e raised to minus 1 by A e raised to beta Ei should be greater than or equal to 1. And this 1 by A, that is 1 by A, or we can write this in terms of alpha also, e raised to minus alpha e raised to beta Ei should be greater than or equal to 1. And consider the ground state. Let the energy, the minimum energy E be 0. So in that case, this e raised to 0 is 1. That is e raised to minus alpha, which is equal to 1 by a into e raised to beta a എന്താണ് ഗ്രൗണ്ട് സ്റ്റേറ്റിൽ e raised to 0, that is 1. e raised to 0 is 1. And 1 by a is greater than or equal to 1. That is രണ്ട് സൈഡിലും ഒരു a കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്താൽ 1 should be greater than or equal to a. തിരിച്ചെഴുതിയാൽ a should be less than or equal to 1. So that is the maximum value of a. Maximum value of a എന്ന് പറയുന്നത് 1 ആണ്. Then from this equation, the minimum value of a is ni is gi by 1 by a e raised to beta i minus 1. ഇത് എപ്പോഴും പോസിറ്റീവ് ആയിരിക്കണം. ഇതൊരു നെഗറ്റീവ് നമ്പറാണ് അല്ലേ, മൈനസ് ഐ ആണ്. ഇതെപ്പോഴും പോസിറ്റീവ് ആയിരിക്കും because the minimum value of ei is 0 and beta is 1 by kt, ഒരു പോസിറ്റീവ് നമ്പറാണ്. So 1 by a cannot be negative അല്ലേ. 1 by a നെഗറ്റീവ് ആയാൽ രണ്ട് ഡിനോമിനേറ്ററിലെ രണ്ട് ടേമുകൾ നെഗറ്റീവ് ആവും. സോ ദ ടോട്ടൽ വാല്യൂ വിൽ ബി നെഗറ്റീവ് and that is not possible. So 1 by a cannot be negative. Cannot be negative എന്ന് പറഞ്ഞാൽ greater than or equal to 0 അല്ലേ. So this is the condition for a. A is between 0 and 1. And so we have the condition for the parameter a where a is e raised to minus alpha. അപ്പോൾ എയുടെ വാല്യൂസിൻ്റെ മാക്സിമം വാല്യൂ മിനിമം വാല്യൂ ഇതാണ് നമ്മൾ കാൽക്കുലേറ്റ് ചെയ്തത്. Then we calculate the number of eigenstates in momentum space between momentum p and p plus dp. So this is p and again this is p plus dp. The radius p plus dp. Here the radius is p and in between there is the shell and the volume of this shell is 4 pi p square into this thickness. This is dp, 4 pi p square dp. That is the volume occupied in between the momentum p and p plus dp. Volume കിട്ടി. Now we need to find the number of eigenstates അല്ലേ. number of eigenstates അറിയണമെങ്കിൽ volume divided by the volume occupied by one eigenstate in momentum space. So phase space, we know the phase space is a combination of momentum space and momentum space and the physical space. Physical space in momentum space in combination and a phase space, and the elementary volume in phase space is dpx dpy dpz into dx dy dz, and this is the physical volume and this is the volume occupied in momentum space. In total, dpx into dx is h, dpy into dy is h, and dpz into dz is h. That is h cube is equal to this physical volume. This is a physical volume dx dy dz into the momentum space volume or the volume occupied in momentum space. So we need to find the volume occupied by one eigenstate in momentum space. That is, we need to get this value, volume occupied by one eigenstate in the momentum space. Phase space the volume occupied is h cube, and in momentum space the volume occupied is h cube divided by v. h cube എന്ന് പറയുന്നത് മൊമെൻറ്റം സ്പേസിൻ്റെയും ഫിസിക്കൽ സ്പേസിൻ്റെയും കൂടെ കോമ്പിനേഷനാണ്. സോ ദ വോളിയം occupied by one eigenstate in momentum space is h cube divided by v. So here h cube by v, or eigenstate momentum space occupy the volume, that is h cube by v, and this is the total volume. And so we get the number of eigenstates in the momentum space between p and p plus dp, and it should be multiplied by the spin degeneracy factor gs, and gs is equal to 2s plus 1. Spin degeneracy factor on gs is equal to 2s plus 1, whereas is the spin. So here we are going to calculate the value for particles with zero spin. So zero spin in the case s 0 ആണ്, so gs is equal to 0 plus 1, gs is equal to 1. അപ്പോൾ സ്പിൻ സീറോ പാർട്ടിക്കിളിൻ്റെ കേസിലാണ് നമ്മൾ ഡിറൈവ് ചെയ്യാൻ പോകുന്നത്. That is gp dp, the number of eigenstates within p and p plus dp. Degeneracy factor is 1 because we are considering only spin zero particle. Then 4 pi p square dp by h cube by v. And from this, now we are going to calculate n p dp, and that is equal to gp dp by e raised to alpha plus beta ei minus 1. Since the levels are continuous, we can take this as np dp and gp dp. And then we substitute the equation for gp dp, that is v by h cube. We are substituting this equation, v by h cube 4 pi p square dp divided by e raised to alpha plus beta ia minus 1, and that is np dp. Then let this be equation 2, and at left side it is np dp. This ei is equal to p square by 2m, and therefore np dp can be written as v by h cube 4 pi p square dp by e raised to alpha plus beta is p square by 2m minus 1, and this is np dp. Now we are going to write n e d. The difference is that we are going to convert p in terms of e. അപ്പോൾ പി എ ഇയുടെ ടേംസിലേക്ക്, മൊമെൻറ്റത്തിനെ എനർജിയുടെ ടേംസിലേക്ക് എക്സ്പ്രസ് ചെയ്യുന്നു എന്ന് മാത്രമേ ഉള്ളൂ. and we are using this relation. E is equal to P square by 2m. So now we are going to convert equation 3 in terms of E. So what we have is this equation NP dP is equal to 4 pi V by H cube P square dP divided by e raised to alpha plus P square by 2m into beta. Beta is 1 by kt. This is kt. Kt minus 1 and e is equal to P square by 2m. That is d differentiate ചെയ്താൽ P square differentiate ചെയ്താൽ 2p dp by 2m. M is a constant. Here p square dp അല്ല p square dp എന്ന് പറഞ്ഞാൽ p into p dp ആണ്. P square is p into p and we can substitute for this p dp. Here from this p dp is m into d. So here it is p into here it is p into p dp and p is 2m e raised to half. P square എന്ന് പറയുന്നത് 2me ആണ്. That is p is root of 2me. pme raised to half. That is 4 pi v by h cube. Here it is np dp. Then p into p dp. P is root of 2me. That is 2me raised to half. And p dp is md. m d by e raised to alpha plus p square by 2m. P square by 2m is e. E by kt minus 1. And then we can write this in terms of x. ഇപ്പോൾ ഇതിനെ ഇൻ്റഗ്രേറ്റ് ചെയ്യാനുള്ള എളുപ്പത്തിന് വേണ്ടിയിട്ടാണ് എക്സിൻ്റെ ടേംസിലേക്ക് എഴുതുന്നു. where x is e by kt. X is e by kt means dx is de by kt. K യും t യും കോൺസ്റ്റൻസ് ആണ്. സോ dx is de by kt. ഇപ്പോൾ ഡിക്ക് പകരം kt dx എഴുതാം. അതുപോലെ ഈ ഉള്ള ടേമുകളെല്ലാം എക്സിൻ്റെ ടേംസിൽ റീപ്ലേസ് ചെയ്യാം. ഈ ഉള്ള ഏതൊക്കെ ടേം ഉണ്ട് ഇവിടെ? e is here, then d is here, then e is here. ഇപ്പോൾ ഇവിടെ 3 e ഉള്ള 3 ടേമുകൾ, ആ 3 ടേമിനെയും എക്സിൻ്റെ ടേംസിലേക്ക് കൺവേർട്ട് ചെയ്യാൻ പോവാണ് ഫോർ ദ ഈസ് ഓഫ് ഇൻ്റഗ്രേഷൻ. That is, this is equal to NPDP അല്ല, NPDP നമ്മൾ ഈയുടെ ടേംസിലേക്ക് മാറ്റി. that is NED. Now that is equal to 4 pi v by h cube 2m raised to half, then ktx raised to half m kt dx divided by e raised to alpha plus e by kt. E by kt is x minus 1. and this is equal to this 4. We can write this 4 as 2 into 2. Then here it is 2 raised to half. 2 raised to half into 2. That is 2 raised to 3 by 2. ഇപ്പോൾ ഇവിടുന്ന് ഒരു 2 and 2 raised to half from here. Both 2 raised to 3 by 2. രണ്ട് multiply ചെയ്താൽ 2 raised to 3 by 2. And there is a 2 left. Here 2. Then multiply by root pi by root pi. root pi by root pi കൊണ്ട് multiply ചെയ്താൽ pi raised to 1 by 2 ഉണ്ട്. Here it is pi. Pi raised to 1 by 2 into pi. That is pi raised to 3 by 2. So 2 pi. Then kt raised to half and kt. That is kt raised to 3 by 2. And here m raised to half. Then here, yeah, m raised to half into m is m raised to 3 by 2. അങ്ങനെ 3 by 2 ഉള്ള ടേമുകൾ കമ്പൈൻ ചെയ്തു. പൈയിൽ 3 by 2 ഇല്ലായിരുന്നു. ഇപ്പോൾ ഒരു റൂട്ട് പൈ നമ്മൾ ഇൻട്രൊഡ്യൂസ് ചെയ്തു. റൂട്ട് പൈ ബൈ റൂട്ട് പൈ. ആൻഡ് ദെൻ 2 raised to half into a 2 from here. That is 2 raised to 3 by 2. 2 is left. And now it is 2 pi m kt raised to 3 by 2, 2 by h cube. Then here it is root pi e raised to alpha plus x minus 1 into x raised to half dx. And this is the equation 14 given in text. So here first we considered the Bose-Einstein gas, the Bose-Einstein distribution function. Then we introduced a parameter a, where a is e raised to minus alpha. The number should always be positive. From that a, we got the limit for a. A should be between 0 and 1. Then we find the number of eigenstates in momentum space between the momentum p and p plus dp. Then using E is equal to p square by 2m, we converted that into NE d.